Imagine gazing into the cosmos and discovering a galaxy spinning the wrong way. Not just a cosmic hiccup, but an astronomical mystery. Most galaxies swirl in harmony, following a universal spin, but some rebels defy this dance, twisting in reverse. Why would a galaxy break the rules of cosmic motion? What secrets do these backward galaxies hide? Today we dive into the bizarre world of galaxies that spin the wrong way, and what they could reveal about the dark side of the universe. Galaxies rotate due to the conservation of angular momentum from the early universe. Most spiral galaxies spin in a predictable direction, which astronomers have studied for decades. This spin affects everything, from how stars form to how galactic arms are structured. When viewed from Earth, some spin clockwise, others counterclockwise. But this depends on our viewpoint. What truly matters is whether their spin aligns with the cosmic average. So what happens when some galaxies don't follow the norm? In the vast Sloan Digital Sky Survey, SDSS, astronomers identified galaxies that appear to spin in the opposite direction to their neighbors. These reverse-spinning galaxies challenge our understanding of galaxy formation. Out of thousands studied, a significant number didn't conform. They weren't merely optical illusions. These galaxies truly defy cosmic trends. This discovery began with Galaxy Zoo, a citizen science project inviting people to classify galaxies. Volunteers noticed a pattern. Some galaxies rotated differently. When experts analyzed the data, the oddity held up. This crowdsourced anomaly became a scientific curiosity, leading to deeper research. From Earth, whether a galaxy spins clockwise or counterclockwise is usually a matter of perspective. But statistically, across the observable universe, spins should average out evenly. So when researchers found a spin bias, they questioned, is this a random chance or evidence of something deeper in the structure of the cosmos? Galactic spin is believed to originate from primordial gas clouds and their interaction with dark matter halos. As these clouds collapsed under gravity, they began spinning. Over billions of years, this spin becomes a galaxy's identity. But this process assumes symmetry and order, not reverse motion. NGC 4622 is a spiral galaxy in the Centaurus constellation that shocks scientists. Its outer arms spin in reverse, while the inner core spins normally. It's like a galaxy trying to do a backflip in slow motion. Astronomers confirm this by analyzing its Doppler shift, a method that reveals motion by observing changes in light frequency. One theory suggests galactic collisions can flip a galaxy's spin. When galaxies merge, their angular momenta can cancel or reverse, especially if the impact is off-center. These encounters are violent, tearing stars from orbit and altering entire spin patterns. Could backward galaxies be survivors of cosmic accidents? Sometimes larger galaxies absorb smaller ones, a process called galactic cannibalism. If a dominant galaxy swallows a satellite with a counterspin, it may inherit some reverse angular momentum. Over time, this could shift or distort the host's natural spin. Dark matter is an invisible substance that makes up most of a galaxy's mass. It forms a halo around galaxies, guiding how they rotate. Some scientists believe disturbances in these halos, perhaps from nearby structures, might cause spin anomalies. If dark matter is uneven, it could warp rotational motion. When researchers analyzed galaxy spins across vast distances, they noticed a possible directional preference. Some sectors of the universe had more clockwise galaxies, others counterclockwise. This could hint at a large-scale asymmetry in the universe, something not predicted by the Big Bang model. This term refers to an unexpected alignment in the cosmic microwave background, CMB. It's a controversial concept, but some theorists link galaxy spin directions to this anomaly. If true, it challenges the idea of an isotropic universe, where everything should be uniform in all directions. Critics argue that human perception and telescope calibration bias could skew the data. Early studies might have overestimated reverse galaxies due to mirroring errors in telescope imaging. However, with advanced algorithms and multiple independent surveys, the anomaly has persisted. Some physicists speculate that galactic spin reversals might hint at quantum-scale influences on a macroscopic level. Could the universe have a handedness like particles do? If galaxies reflect a universal chirality, then reverse spinners could be part of a much deeper quantum pattern. In fringe theories, reverse-spinning galaxies are seen as potential glitches in a simulated universe. If the cosmos is a programmed environment, inconsistent spins might be errors in rendering physics across different regions. This idea borders science fiction, but it stirs imagination. If spin direction isn't random, it might reshape how we understand the cosmic web, dark matter flow, and early universe conditions. Reverse spinning galaxies might act as cosmic breadcrumbs, pointing toward underlying physical laws yet to be discovered. Projects like the Dark Energy Survey and LSST aim to map billions of galaxies. By cataloging spin directions on a massive scale, scientists can identify patterns, maybe even uncover rotational asymmetries in the large-scale structure of the universe. These maps might reveal whether spin is random or part of a cosmic choreography. Could reverse spinning galaxies tell us something about time itself? Some theorists wonder if these galaxies reflect a reversal in entropy, a sign that the arrow of time may behave differently at vast scales. While speculative, this idea draws a deep connection between time, entropy, and cosmic motion. Scientists have begun analyzing whether reverse spinning galaxies produce stars differently, contain more gas, or show anomalies in black hole activity. Some findings suggest differences in star formation rates, hinting that spin direction might affect how galaxies evolve. Spiral galaxies get their beautiful shapes from density waves. These arms trail behind the direction of rotation. In reverse spinning galaxies, these waves move differently, sometimes leading instead of trailing. This could affect everything from star births to how supernovae spread. Current estimates suggest that only 7 to 10% of spiral galaxies may spin in reverse. That's still millions of galaxies across the observable universe. While not dominant, they're not rare either, which makes the mystery more profound. Some scientists suggest Earth might reside in a local cosmic bubble, a region where spin direction skews abnormally. If true, it could mean our observations are biased by our cosmic position. This theory is controversial, but forces astronomers to reconsider how location affects observation. With AI classification tools and space telescopes like James Webb, astronomers can study spin at earlier cosmic epochs. The goal: see if galaxies have always spun this way, or if something changed over time. These tools could unlock the true origin of spin reversals. Galaxies that spin the wrong way are more than quirky outliers. They might be clues to something deeper. Whether caused by chaotic collisions, dark matter distortions, or something even stranger, they challenge our cosmic assumptions. One thing's clear: the universe isn't just vast, it's wonderfully weird.